Quantum Leap, Real-World Quantum Computing in 2026.
Hello everyone, you are on the Digital Fresh channel.
Imagine for a single breathless moment that you are sitting in a control room, surrounded by the low, resonant hum of machinery that operates colder than the void of deep space, and on the screen before you, a complex web of molecular bonds, a problem that has stumped the world's most powerful supercomputers for decades, begins to unravel itself in a cascade of elegant, impossible logic. Not because of a simple calculation, but because the machine you are watching is not just computing the answer, it is, in a sense, becoming the answer. Its fundamental particles dancing in a choreographed ballet of probability and superposition. A dance that is no longer the stuff of theoretical physics textbooks, but is, right now, in the year of our Lord 2026, driving tangible, world-altering breakthroughs in medicine, finance, and the very infrastructure of our global civilization. A quiet revolution unfolding, not with a bang, but with the delicate, precise click of a quantum gate being closed. A revolution that is moving with terrifying speed from the sterile halls of national laboratories into the boardrooms of the world's most powerful corporations, transforming the impossible into the merely difficult, and the difficult into the routine. A revolution whose first faint tremors you can feel in the news, in the stock market, and perhaps most profoundly in the hope it offers for curing diseases that have haunted humanity for generations. And the question that hangs in the air, thick with the ozone scent of progress, is not if this technology will change your life, but precisely how soon, and what you will be doing when the first truly life-saving drug, designed not by a human hand, but by the cold, brilliant logic of a quantum processor, arrives on the shelves of your local pharmacy. A tiny white pill that is the physical embodiment of a new scientific epoch. Today, we are not here to discuss the science fiction of tomorrow. We are here to document the startling, exhilarating, and very real world of quantum computing in the year 2026, a year that many experts now point to as the definitive turning point, the moment when the decades of theoretical groundwork, the billions of dollars in investment, and the tireless efforts of thousands of scientists finally coalesced into something that is no longer just a promise, but a powerful, practical tool. A tool that is already optimizing the delivery routes for your online orders, fortifying the digital walls that protect your life savings, and simulating the intricate dance of proteins inside a human cell with a fidelity that was previously unimaginable. A tool whose development is being spearheaded by titans like IBM, whose Nighthawk processors are now pushing the boundaries of quantum volume to handle up to 7,500 quantum operations by the end of this very year.
And Google, whose researchers have not only developed but experimentally validated a quantum algorithm capable of teasing out the structure of complex molecules with a speed and accuracy that leaves even the most advanced classical supercomputers in the dust. And Quantinuum, whose trapped ion systems are setting new global standards for gate fidelity, pushing the error rate so low that the dream of an error-corrected, fault-tolerant quantum computer is no longer a distant star, but a horizon that is rapidly coming into view. A horizon upon which we can already see the silhouettes of the first commercial applications that are not just proofs of concept, but genuine, revenue-generating, problem-solving engines driving real-world innovation forward at a breakneck pace. The journey to this point has been a long and winding one, a path littered with discarded theories, technological dead ends, and moments of profound doubt, where the sheer fragility of the quantum state, where a single stray photon or a whisper of heat can collapse the entire delicate edifice of superposition and entanglement, seemed like an insurmountable barrier, a fundamental law of nature conspiring against progress. But the human spirit of inquiry, that relentless drive to understand and to master, refused to be deterred. And instead of trying to build a monolithic, perfect quantum computer all at once, the field underwent a profound strategic shift towards what is now known as the era of hybrid quantum classical computing. a pragmatic and brilliant approach where quantum processors are not asked to do everything, but are instead deployed as specialized coprocessors, hyper-focused accelerators for the specific tasks where their unique properties give them an undeniable and increasingly demonstrable advantage. Tasks that involve navigating vast combinatorial landscapes of possibility, simulating the behavior of other quantum systems like atoms and molecules, or solving complex optimization problems where the number of variables explodes into infinity for a classical machine. And it is within this hybrid paradigm that the first truly useful applications have taken root and begun to flourish, moving quantum computing out of the realm of pure academic curiosity and into the concrete, results-driven world of industry, where the bottom line is the ultimate arbiter of truth, and where the early adopters are already reaping the rewards of their foresight and courage in embracing this nascent yet potent technology. A shift in focus that marks the definitive end of the potential technology phase and the unambiguous beginning of the practical products era. A transition that is not merely incremental, but represents a fundamental reorientation of the entire field towards tangible value creation and real-world impact.
Nowhere is this shift more dramatically evident, more viscerally felt than in the high-stakes, high-reward world of pharmaceutical research and drug discovery, an industry where the path from a promising idea to a life-saving medicine is a gauntlet of staggering complexity, cost, and failure, a process that traditionally takes over a decade and costs more than $2 billion, with a failure rate that hovers around a devastating 90%. A process that is fundamentally bottlenecked by our inability to accurately simulate the quantum mechanical interactions that govern how a potential drug molecule will bind to a protein target inside the human body. A problem so complex that even the most powerful supercomputers are forced to rely on crude approximations, like trying to navigate a ship through a storm using a map sketched on a napkin. But in 2026, that is beginning to change, profoundly and irrevocably, as quantum computing steps in to provide the computational microscope that scientists have dreamed of for generations, allowing them to model these interactions not with approximations, but with a level of quantum mechanical precision that was previously the exclusive domain of nature itself. A capability that is no longer confined to theoretical papers, but is being actively deployed in real-world case studies, such as the pioneering work undertaken by the global biotechnology firm Biogen in collaboration with Accenture, where quantum algorithms are being used to accelerate the early stages of pharmaceutical research and development, specifically in the area of target identification and lead optimization. Processes that are critical for improving patient outcomes and bringing new therapies to market faster. And even more compelling is the landmark study published in late 2025, which documented the very first time a quantum computer was used to experimentally identify a potential drug candidate, a hit, marking a historic milestone where the theoretical power of the technology was translated into a concrete physical molecule that could one day become a medicine. A tangible proof that quantum computing is not just a faster calculator, but a fundamentally new way of thinking and designing matter. A new paradigm for scientific discovery that promises to compress years of laboratory work into weeks, to turn the tide against diseases like Alzheimer's and certain aggressive forms of cancer by allowing researchers to simulate the misfolding of proteins or the intricate signaling pathways of a tumor cell with unprecedented fidelity, offering a glimmer of hope where there was only frustration, and transforming the pharmaceutical industry from a slow empirical science into a predictive engineering discipline.
The ripples of this quantum wave are not confined to the life sciences. They are spreading with equal force through the complex, interconnected, and hyper-competitive world of global finance, an industry built on information, probability, and the constant, relentless search for the slightest edge, the most minuscule inefficiency to be exploited. And in this domain, Quantum computing is emerging as the ultimate strategic weapon, a tool for navigating the labyrinthine complexities of modern markets with a clarity and speed that borders on precognition, particularly in the critical area of portfolio optimization, the art and science of constructing a basket of investments that maximizes return for a given level of risk, a problem that when scaled to the universe of thousands of assets, myriad constraints, and dynamic market conditions becomes a computational nightmare for classical systems, a nightmare that institutions like HSBC and JPMorgan Chase are now actively solving with quantum hardware, with HSBC having demonstrated a real-world application of a quantum algorithm specifically designed to balance risk and reward within its vast investment portfolios, and JPMorgan Chase, in a deep and ongoing collaboration with IBM, rigorously evaluating quantum algorithms for the precise and lightning-fast pricing of complex financial derivatives, a task where milliseconds can translate into millions of dollars. And the implications of this are staggering, moving far beyond simple optimization to the very bedrock of financial security, as quantum computing simultaneously presents the greatest threat and the most powerful shield to modern cryptography, with the looming specter of a large-scale quantum computer capable of breaking the RSA and ECC encryption that secures every online transaction, every bank transfer, and every state secret, a threat that has spurred the entire industry into action, accelerating the development and deployment of quantum-resistant cryptographic algorithms, a digital arms race where the banks are not just preparing for the future, but are actively using quantum-inspired methods today to protect their AI-powered trading systems from the very technology they are helping to build. A paradoxical dance of creation and defense that underscores the immense dual-natured power of this technology, a power that is forcing financial institutions to fundamentally rethink their entire technological infrastructure, their risk models, and their long-term strategic planning, making quantum literacy not a niche skill for physicists, but a core competency for the next generation of financial leaders. And then, woven into the very fabric of our daily lives is the third major frontier where quantum computing is making its presence felt in a deeply practical way: the vast, intricate, and often frustratingly inefficient global logistics network, the arteries through which the lifeblood of our consumer economy flows, a system of staggering complexity involving millions of vehicles, billions of packages, and a near infinite number of possible routes, schedules, and contingencies. A system where a tiny improvement in efficiency can translate into billions of dollars in savings and a significant reduction in the carbon emissions that are choking our planet. And it is here, in the gritty reality of warehouse management and delivery routing, that the abstract power of quantum algorithms is being translated into concrete, measurable results, with industry giants like DHL forging powerful partnerships with IBM to develop and deploy quantum-inspired algorithms that optimize delivery networks with a sophistication that was previously impossible. Algorithms that don't just find the shortest path on a map, but dynamically factor in a dizzying array of real-world variables: customs clearance delays at international borders, fluctuating fuel prices, live traffic data, weather disruptions, and the unique constraints of a driver's shift, creating a logistical symphony that is constantly self-correcting and optimizing in real time, a capability that was dramatically showcased by Volkswagen several years ago when they used a quantum algorithm to optimize the traffic flow of 10,000 taxis in Beijing, a proof of concept that is now matured into a standard tool in their operational arsenal, and a capability that is being expanded by companies like Unisys, who intend to broaden their quantum logistics solutions to cater to an even wider range of industrial clients by the end of 2026, a quiet revolution that means the package you ordered online might arrive not just faster, but via a route that is mathematically perfect, its journey a testament to the power of quantum mechanics applied to the mundane, transforming the chaos of global commerce into a system of elegant, efficient order, and proving that the most profound technological revolutions are not always the loudest, but are often the ones that simply make the world work a little bit better, a little bit smoother for everyone. As we stand here in the early days of January 2026, looking back on the whirlwind of progress that has brought us to this precipice, it is impossible not to be filled with a sense of awe and a profound, almost giddy anticipation. For we are no longer passive observers of a distant future, we are active participants in its construction. and the tools at our disposal are more powerful than ever before. Tools that are moving with astonishing speed from the realm of scientific marvel into the domain of practical utility. Tools that are not waiting for some mythical quantum winter to pass, but are being forged in the fires of real-world necessity and deployed to solve the most pressing challenges of our time, from the microscopic battlefield inside a human cell to the macroscopic chess game of global finance and logistics. And the most incredible part of this story is that we are only just getting started. The current generation of noisy, intermediate-scale quantum devices is merely the prologue, the opening chapter in a much larger narrative. A narrative that will soon be dominated by the advent of error-corrected, fault-tolerant machines. Machines that will not just accelerate existing processes, but will unlock entirely new domains of science and engineering, enabling us to design revolutionary new materials for clean energy, to create hyper-accurate climate models that can predict the impact of our policies with certainty, and to unlock the deepest secrets of the universe itself. A future that is not a vague hope, but a destination we are navigating towards, with a map drawn in the language of quantum mechanics. And so the call to action is clear, urgent, and exhilarating. Do not turn away from this. Do not dismiss it as too complex or too far removed from your daily life, for it is not. Instead, dive in, seek out the knowledge, ask the questions, challenge the assumptions, and become a part of this extraordinary human endeavor. Subscribe to the channels that explain it, read the articles that explore it, and engage in the conversations that will shape its ethical and equitable deployment. For the quantum leap is not a single solitary event, but an ongoing collective journey. And the most important question is not what this technology will do, but what we, as a global community of curious, compassionate, and courageous individuals, will choose to do with it. A choice that begins with the simple, powerful act of wanting to understand, of leaning in, and of saying with unwavering conviction that the future is not something that happens to us, but something that we, together, have the power to create. One qubit, one discovery, and one inspired idea at a time.
I hope you enjoyed this video. Subscribe to the channel and turn on the bell.